it's too low.
Okay.
I think
So
we are.
We can start.
Yeah, we can start. Aldemita, we can start.
Yes. Yes, sir.
So good afternoon, everyone, and welcome. I welcome all of you to this webinar being conducted by ISAAA on the global impact of biotech crops, economic and environmental effects 1996 to 2018. My name is Kaundinya. I'm the Director General of the Federation of Seed Industry of India. We have all the research-based seed companies and biotech companies as members of our association. I invite all of you, all the participants to this webinar. This is an interesting subject on which we have always heard many webinars and many viewpoints. So I think this is also an occasion and an opportunity to put forward some of the correct positions on the technology. There is a Q&A button and a chat button. Please post your, during the course of the seminar, if you have any questions, please post them on the Q&A button, and we will try to answer as many questions as possible towards the end. Please keep all the microphones on mute so that we are not disturbing the speakers. We have a very eminent panel today and very good speakers. So we hope to have some very interesting talks by them and also good discussions. So please keep your microphones on mute when you are not speaking. Selected questions will be raised during the course of the meeting. There will be a question and you will be asked to answer the question. So that will happen a couple of times during the course of the seminar. So please do participate in that poll, what we call the poll, right? So let me straight away get into the panel. We have, and I will go in the order of the presentations. So I will first introduce Dr. Aldemita. Dr. Rhodora Aldemita is the Director of Global Knowledge Center and the Southeast Asia Center of the International Service for Acquisition of Agri Biotech Applications. She is based in Philippines. She leads the development and publication of the annual global status of commercialized biotech GM crops or what are called as ISAAA briefs. She coordinates the activities of ISAAA's Biotechnology Information Centers in 15 countries and capacity building activities on biotechnology and biosafety in Southeast Asia. She is a member of the technical advisory team of the DA Biotech Program Office, which a board member of the Biotechnology Coalition of the Philippines and editor-in-chief of the Philippines Journal of Crop Science. Dr. Aldemita holds a PhD in botany from Purdue University, USA, and a postdoctoral fellowship at Albert Ludwigs University, Germany, on golden rice. So her work in Germany was on golden rice. So we are keenly looking forward to your talk, Dr. Aldemita, and now I hand it over to you.
Yeah, we can, it's okay. We can move to Graham.
So you will come back later?
Yes, please.
Okay.
Thank you.
So let's have, I think by the time Dr. Aldemita sets right her presentation, we will have the presentation of Dr. Graham Brookes. Graham Brookes is a well-known name to many people also in India because of the studies he has been doing on the impact of the technology. He is an agricultural economist and a consultant with more than 30 years experience of examining economic issues relating to the agricultural and food sectors. He is a specialist in analyzing the impact of technology, policy changes, and the regulatory impact. He has, since the late 1990s, undertaken a number of research projects relating to the impact of agricultural biotechnology and written widely on this subject in peer-reviewed journals. This work includes frequent updates of a global economic and environmental impact of GM crops report, the impact of insect-resistant maize in Spain and herbicide-tolerant soybeans in Romania, the impact of GMO labeling and GMO avoidance in Europe, the economic impact of GMO zero tolerance legislation in the EU, the cost to the US economy of failure to embrace agricultural biotechnology, the economic impact of biosafety legislation in Turkey, and studies of the potential impact of using crop biotechnology in the Ukraine, Russia, Thailand, Indonesia, and Vietnam. So, Graham Brookes, it's over to you for your presentation. Thank you.
Thank you. Okay, are we functioning on the technology?
Yes.
Yes.
Okay.
Good for you.
Good afternoon, ladies and gentlemen. I'd first of all like to thank ISAAA for inviting me to present to you this afternoon. What I'm going to present to you in the next 20 to 25 minutes is our 14th annual review of the impact of GM crop technology around the world. We have been undertaking this work now for about 15 years, and the material I'm going to present to you today is the latest update. In relation to my experience, I'm an author or a co-author now of more than 30 papers on the impact of this technology around the world. That's 30 papers in peer-reviewed journals. And for those of you who want more information on the presentation that I'm doing today, here are the two links to the journal GM Crops where you can download the papers. They are available on open access, so there's no charges to accessing those documents. And for those of you who might want even more detail, there is a longer, more than 200-page version available from our website at the address shown at the bottom of the slide. The latest impact report covers the period from 1996 to 2018. We look at three main aspects: on the socio-economic side, the impact on farm income and productivity, and on the environmental side, two aspects associated with changes in pesticide usage and greenhouse gas emissions. Methodology: how have we undertaken the work? We essentially review and use the increasingly considerable literature available on the impact of the technology that has developed over the last 25 years. We also undertake some of our own analysis because, as you may or may not realize, there's not analysis available of every trait in every country for every year. So we have to do some of our own analysis and extrapolation of other people's work. To try and make the analysis as accurate and up to date as possible, we make use of current prices, yields, exchange rate information. We review pesticide usage information and make comparisons between typical treatments on conventional versus GM crop alternatives. And lastly, we review the literature on carbon impacts, mainly related to fuel changes and soil carbon, but I'll explain that further later in the presentation. This slide actually gives you a summary of the key findings of the report, which I will discuss in more detail, but I thought it was worthwhile putting this slide up at the start. Essentially, over this period of analysis, we estimate that the technology has resulted in a reduction in pesticide usage of 776 million kilograms less active ingredient used. That's an 8.6% reduction. But in terms of the impact on the environment as measured by the EIQ indicator, again, I'll come on to that in more detail, it is a larger 19% reduction. For the farmers who've used the technology, they've seen their incomes increase by an aggregate amount of $225 billion in extra farm income. The technology is delivered mainly through higher yields, 824 million tons of more food, fibre and feed, and carbon emissions, example of 2018, the technology has contributed to reducing global emissions by 23 billion kilograms less carbon dioxide being released into the atmosphere. In terms of the farm income gains, in 2018, the reduction has been the increase in farm income has been equal to $19 billion worth of extra farm income. In relation to the four main crops where this technology is used, corn, canola, cotton and soybeans, this is roughly equal to adding 5.8% to the value of the global production of those four crops. As I indicated, the cumulative gain is 225 billion. And if you average that gain over the area that has been planted to crops using the technology, it works out as an average gain of $97 per hectare. And interestingly, if you split that income, that increase in income share between developed and developing countries, it's roughly 50-50, although the balance is in favor of 52% of developing countries. This slide gives you the spread of the average farm income gain by country. And the key take-home message from this is that the highest levels of farm income gain have tended to be in developing countries. But again, I'll speak more about this in following slides. This slide gives you a spread of the farm income gains by country, and you can see here that United States farmers have gained the most from using the technology. This is not surprising, really, given that American farmers were the first to adopt this technology in a significant way in the late 1990s. And by about 2005, 2004, more than 90% of all four of those crops have been using the technology in the United States. You'll also see the significant contributions that gains have given to other countries in South America, like Argentina and Brazil, and through the use of insect-resistant cotton in India and China. I think it's also worth recognizing that there are other reasons why farmers quite like this technology, other than just the straight dollar gain that they may have got from using the technology. And this slide gives you a summary of some of those impacts. I won't go through them all, but if you look at the herbicide tolerant crops, many farmers talk about the benefits they get from greater flexibility and convenience in how they can farm, and how it's facilitated them moving away from a plough-based to a no-tillage production system. On the insect-resistant crop side, many farmers refer to the benefits of helping them reduce their production risk. Essentially, they worry less about the extent to which a pest may be destroying their crops. And in the case of a crop like cotton, where traditionally it's been subject to a lot of applications of insecticides, often by farmers using little or no protective equipment, the technologies helped significantly reduce the number of insecticide applications, which has resulted in improved health for farmers and farm workers. This slide, more than any other in my presentation, probably gives a flavour of why a lot of farmers adopt this technology and then stay in it. This summarises the returns on the investment. So if you take the gross benefit of the technology, inclusive of the cost of the technology, because farmers typically have to pay higher prices for the seed to use the technology, you can see that the average cost of the technology when related to the total benefit has been 27% of the total benefit. And in developing countries, the total cost has been 23%. So in terms of returns on investment, you can see that for every extra dollar that a farmer spends in buying the biotech seed, they're getting on average a $3.75 return on their investment. And in developing countries, the average return is even higher at $4.42 per hectare, per dollar. These are extremely high and very significant returns on investment, and more than any other reason, as I've said, give a clear indication of why the technology has been popular with many farmers who've adopted it. In terms of where are these benefits coming from, 72% of them are coming from yield gains, with the remaining gains coming from reductions in the cost of production. Very broadly, the yield gains are coming mostly from the insect-resistant technology, and the cost savings mostly from the herbicide-tolerant technology. And lastly, the yield gains are greatest in developing countries, and the cost savings tend to be greatest in developed countries. I've now got 2 or 3 slides looking at the impact of the insect-resistant technology by crop. This slide gives you an indication of the average yield gains that have been achieved by farmers using this technology. So in corn, across all the countries that have used the technology, the average yield gain has been 16.5%. And you can see the variations by different countries. And that largely reflects the extent of pest pressures and the damage that pests are causing to farmers, and how effective or ineffective the alternative conventional control mechanisms were. Note that the highest yield benefits are tended to be in developing countries again, like the Philippines, Colombia, Honduras. In relation to cotton, the same analysis, average yield gain 13.7%, highest yield gains in developing countries, including India, although I have a specific slide on cotton in India in a minute. Insect-resistant soybeans, released in 2013 in South America, where the average yield gain has been 9.5%. You have had some yield gains arising from the adoption of herbicide-tolerant traits, and this slide gives you a summary of some of that analysis. But this is there to just highlight that Some farmers have got yield improvements from using herbicide tolerant technology, from improved weed control mainly, and in South America, how the technology has helped farmers adopt no-till production practices, which has shortened the total production time from point of preparing soil for seed application and harvesting, so that they've been able to grow a second crop of soybean in the same season after weeds. If you then aggregated up all the yield gains from the adoption of the technology and equated them to extra production of the four main crops, this slide shows that the technology over the period from 1996 to 2018 has been responsible for the world producing approximately an extra 278 million tons of soybeans and just under 500 million tons more corn, and just under 33 million tons of cotton lint, 14 million tons more canola. If you were to then turn that extra production round and say, what would be the extra area of conventional agricultural production that would have been required to have produced that extra production, the next slide gives you an indication of the extra conventional crop area that would have been required if biotech crop technology had not been used in 2018, purely for the 2018 extra production figures. And you can see from that that the world would have had to have planted 24.2 million hectares of additional conventional cropping to those four crops. To give you some context, that's roughly equal to about 38% of the cropping area in Brazil. So it's quite a significant area. Focusing some of the more analysis on India and the use of insect-resistant cotton, introduced in 2002, in 2018, 95% of the crop was using the technology. The average yield impact has been 29% yield improvement. Average farm income gain, $193.56 of extra farm income. Interestingly, if you look at the return on investment for every extra dollar an Indian cotton farmer has spent on the technology, they've got nearly $13 worth of extra farm income. That is at the highest level of the range of performance and return on investment of any of the GM crop technology around the world. None of the technology in any other countries have got to that, to any higher level. That's right at the top level. So it's a very impressive performance and probably gives you a clear indication of why 95% of Indian cotton farmers use this technology and consistently have stayed with using it. In terms of aggregated benefit, it comes out at $24 billion worth of extra farm income since 2002, and it's resulted in an increased production of 14.73 million tons of extra cotton lint. Just to give you a comparison of the use of stacked corn, herbicide tolerant and insect-resistant corn in Vietnam. This comes from a paper that I co-authored that came out only 2 or 3 weeks ago related to Vietnam. And you can see here the significant yield impact returns that Vietnamese farmers have got from using the technology. And interestingly, their average returns on investment, depending on the yield comparisons you use, are getting up to close to the levels of return on investment that the Indian cotton farmers have got. Moving on to impact on pesticide use. Since 1996, the use of pesticides on the biotech crop area has fallen by 776 million kilograms of active ingredient. That's 8.6% reduction. Give you context, that's equivalent to 1.6 times the annual amount of pesticide active ingredients put on crops in China. In terms of the associated environmental impact, as measured by the EIQ indicator developed at Cornell University, it's a larger 19% reduction. The largest environmental gains have come from the use of insect-resistant cotton, where there's been a 32% reduction in the amount of insecticide active ingredient used, and a 35% reduction in the associated environmental impact as measured by the EIQ measure. Interestingly, to give you the context of India, over the period from 2002, we estimate that that's resulted in a reduction of 137 million kilograms less insecticide applied to the Indian cotton crop. Roughly a third reduction, and a more significant 43% reduction in the associated environmental impact as measured by the EIQ indicator. Moving on to greenhouse gas emissions, the technology essentially contributes to lowering greenhouse gas emissions from two main sources. Firstly, reduced fuel use, where mechanical application of pesticides is used. You apply less pesticide, you reduce the fuel use through less spraying, and also there is less soil cultivation associated with farmers moving to no tillage. And that brings me on to the second area where herbicide tolerant technology has facilitated many farmers moving away from a plough based to a no tillage production system. When you plough the soil, you typically release carbon from decaying plant matter. And in fact, ploughing is the single largest source of greenhouse gas emissions from arable crop production systems. So if you move to a no tillage system, you get much less release of carbon from the soil, and leading to additional carbon storage in the soil. In 2018, we estimated that the reduced fuel use was equivalent to a saving of 2.4 billion kilograms less CO2 released into the atmosphere. And the no-till facilitation is a larger 20.6 billion kilogram reduction. Overall, that's equivalent to removing 15.3 million cars off the road for a year, or equivalent to taking 48% of the cars registered in the United Kingdom off the road for a year. A question I often get asked when related to the impact of the technology, well, you presented all this information about positive impacts, what about negatives? Well, the one that often gets raised and is of relevance has been over-reliance on the use of glyphosate by some farmers in North and South America with the use of herbicide-tolerant crops that has contributed to the development of weeds becoming resistant to the herbicides, and has resulted in farmers having to adapt and change their weed control systems. Farmers have essentially had to increase the use of other herbicides to help control weeds that are no longer controlled by glyphosate, and that has increased their cost of production relative to 15 years ago. However, it is important to put that in context, that weed resistance is a problem that occurred before GM crops were available to farmers, and they are equally applicable to all crops grown. And the trend towards increased herbicide use to address weed resistant problems has been equally apparent in conventional crops as it has in herbicide tolerant GM crops. And throughout the period of our analysis of making the comparisons, the environmental profile of the herbicides used on herbicide tolerant crops has continued to have a better profile than its equivalent on conventional crops. And lastly, the herbicide tolerant crops have continued to remain more profitable than their conventional alternatives for the vast majority of farmers using the technology. Bringing my presentation towards its close now, I just put up the slide of the summary again. I won't go through the numbers again, but they're just there for you to see again for a moment. And moving on to concluding comments. If you had to summarize the impacts of the insect resistant technology, it's contributed to giving farmers higher yields, it's reduced their production risk, reduced their insecticide use, and contributed to a more reliable food supply system and the adoption of more environmentally friendly farming methods. The herbicide tolerant technology has given higher incomes, has facilitated extra production, and the adoption of more sustainable farming systems, most notably the adoption of no tillage production systems in North and South America, which has contributed to reducing carbon emissions. Both of the technologies have made important contributions to increasing global production of the four main crops of soybeans, corn, canola, and cotton, and that has resulted in reducing the pressure to bring new land into agriculture. And more recently, we're starting to see new traits such as drought-tolerant corn, fungal-resistant potatoes, insect-resistant brinjal, now being adopted and beginning to contribute positively to both farm income returns and environmentally in the regions where farmers are using these technologies. Lastly, on my last slide, I would say after 23 years of widespread use, I'd say there is now considerable amounts of consistent evidence in peer review literature on the impact of this technology. And the work that I've summarized in my presentation today adds to that literature. Again, for those of you who want to access the material I presented in more detail, the links here are shown to the 2 peer-reviewed papers, and the third one at the bottom, for those of you who may be interested, is the link to the Vietnam paper that we released 2 or 3 weeks ago, all available at the GM Crops and Food Journal website. And I would encourage any of you to read these papers and the references cited in them and draw your own conclusions about the impact of the technology. Thank you very much for your attention, and I look forward later to hopefully answering any questions you may have. Thank you.
Thank you very much, Graham. I think that was a very well articulated presentation on the benefits that we have seen since the introduction of the technology in 1996. And we can very clearly see the benefits in terms of the pesticide reduction, yield improvements, cost benefit ratios, environmental impact in terms of reduction of carbon dioxide emissions, and various other parameters. So thank you very much for that. We do look forward to having more interaction with you. I would now request EJ to put out the question for a poll. Can you do that, EJ, please? So all of you, please look at these questions and answer the question, please.
The questions are to be raised at the end of all that.
That is those are questions in the end. This is just a question from the organizers to the participants to answer. So the question is, what is the most important impact of crop biotechnology that resonates with you? Increase in farm income, decrease pesticide spray, contributes to food security, reduces environmental footprint, all of the above, none of the above. You can click and then submit. Can we have the results, EJ, please? The 10% are saying that increase in farmers' income resonates with them, 7% decrease in pesticide spray, 7% on food security, 3% reduces environmental impact. All of the above, 72%. That's great. Thank you very much. We now move back. We now move forward to go back to Dr.
Aldemita.
Yeah.
Aldemita.
So are you ready now?
EJ is going to share my slide. Okay, I'm
That's
back.
better.
Okay, so actually this is supposed to be an introduction to Graham Brookes' presentation, but I'd like just to show you what happened during the 2018, how much we have gained in terms of hectarage in the country. So let's see the next slide, please. So in 2018, we have this, next slide, please, EJ. Okay, we have this data that we have accumulated from 1996 to 2018, 191.7 million hectares planted to biotech crops. And you can see there that the developing countries is now way ahead of the industrialized countries. We're now putting together the 2019 data, and it looks like it's going to be similar. And next slide, please. The trait shows us that the herbicide tolerance, which used to be very high, is now going down because farmers are looking at the stock traits right now. So here it is currently 80.5 million hectares for the stock traits, 87.5 million hectares for the herbicide tolerance, and 23.7 million hectares for the insect tolerant ones. So our farmers are now getting the feel of how it is to plant stock traits because they do not have to invest much in terms of insecticide and in terms of seeds. And they're not using insecticides anymore, and they are now looking at the no-till technology. Let's move to the next slide. So the next slide shows us that in terms of crops, it is the herbicide-tolerant soybean. Soybean has been increasing, and currently it's still the highest. And it shows us that 50% of all biotech crops planted in 2018 were the herbicide-tolerant soybean. This is followed by maize, cotton, and canola. Next slide, please. looking at the adoption rates, it shows us that in 2018, 78% of the global soybean is already biotech or GM. 76% is cotton, GM cotton. 30% is GM maize, and 29% is GM canola. So we still have a lot of area to be planted to GM maize. And GM maize also has a lot more potential because it can be used for food as well as biofuels and also for livestock feeds. Next slide, please. Now, these are the 26 countries which planted in 2018. So there were 26, 10 in Latin American countries, 9 in the Asia Pacific, where we are, 2 North American countries, 2 in the EU, and 3 African countries. So you can see that India here is number 5 because of its BT cotton. And I know that we have a lot of speakers today who can attest to the benefits of BT cotton in India. Next slide, please. So these are now the top 5 countries which planted in 2018. You can see that USA is the highest. Still, it was 75 million hectares, followed by Brazil, Argentina, Canada, and India. India planted 11.6 million hectares at 95% adoption rate. Next slide, please. So from all of this, we can see that ISAAA is putting together, has already this GMO approval database. And we have from 1992 to 99, since 1992 to 2018, we had 70 countries which have approved biotech crops for food use, feed use, and cultivation. So this includes those countries which do not plant but are importing it for direct use for food and feed. And so we had 4,349 regulatory approvals. USA has the most number of approved events. Maize has the most number of approved events. And the herbicide tolerant maize has the most number of events in both developing and industrialized countries. You can look at our ISAAA website, and we have there the GM approval database that we update regularly. Next slide, please. So this shows to us, this was an old data, and we can see that Graham Brookes has already provided us a lot of information that biotech crops contribute to food security, sustainability, and climate change. And so I thank you very much for your attention, and I hope that we can discuss so much more of this, including the studies of Graham Brookes. Thank you so much.
Thank you very much. That was very brief but very concise and very informative. We move on to Dr. Mayee now. Dr. Mayee doesn't need much introduction to all of you in India. Dr. C.D. Mayee is a renowned agricultural scientist and is the president of the South Asia Biotechnology Center, the SABC, New Delhi. He was formerly Vice Chancellor, MEIU Parbhani, Director, Central Institute of Cotton Research, CACR, Nagpur, and Agriculture Commissioner, Government of India, before retiring as the chairman of ASRB, which is the Agricultural Scientist Recruitment Board. Dr. Mayee promoted the production technologies of cotton, groundnut, sunflower, and coarse cereals. He was associated with the first commercial release of insect-resistant cotton in India and instrumental in developing biotech infrastructure in ISAAA institutions. Dr. Mayee has been Alexander Humboldt Fellow of Germany. He is a recipient of several awards for agricultural development. Dr. C.D. Mayee obtained his agricultural degrees from Maharashtra and PhD from IARI in plant pathology. Dr. Mayee, over to you, sir.
Thank you very much, Dr. Ram. I'll be talking about in the next 15 minutes on the impact of BT cotton in the production and utility in India. May I have the next slide, please? The next slide shows, very clearly shows, I think everybody knows, that we are growing all the 4 species of cotton. What interesting part of the slide is that we have nearly 7.5 million smallholder farmers who have less than 1.5 hectares of land. And that is a very crucial problem Even sometimes I think the estimates are that it could be about 8 million smallholder farmers. So by and large, our holding is very small. I think this slide shows that particular importance. And we have a very robust cotton value chain where we employ nearly more than 50 million people in cotton value chain. The next slide, please. The next slide will show you the, as everybody, I think Graham has also showed, and then Aldemita had very clearly said, but we have still small areas of arboreum in this map of India, herbaceum, barbadans. But all these, they occupy less than total 3%. Now, rest of all is only a hybrid cotton area, and that too BT hybrid. So this is the map of India, and still after 18 years, you can see that the farmers are still growing more. Somebody says about 95%, 11.5 million hectares. I think next slide I will show you. Then next slide, please. You can see the area has now increased to, I think about this was 18. There is a steep increase in area, but there is much more increase in the production and productivity of cotton. Now, if you see, there is a very interesting trend. I always call it that there is some suppression in the last few years in the average productivity. I think that years 15, 16, but now we have managed things very well, and I think now the yields are almost quite stable. Next slide. I will show you the latest figures, which the next slide, please. Next slide, please. This is the latest cotton sowing report of the current season. Now, I think this season very clearly shows that we have now more area of cotton in the country. That means we will be crossing 129, almost 12.9 million hectares of area. And if you see the compound growth rate, highest growth rate was when we had BT cotton. Now there has been slowly a reduction in the productivity areas, and that too I think we are now coming to a new phase, what we call it as a stagnation in the cotton yield. Next slide, please. I always call Indian cotton a very unique situation. Whenever we brought some improved technology, there was a jump, but there are phases, yield acceleration. And this yield acceleration phases, if you see, since independence of cotton, now you can see 202, the inter and multiple gene BT cotton yields, they have tremendously gone up. So this is where I always call it, because there used to be always stagnation. Now a time has come that should India go in for what we call it as HTBT cotton. I will show you in the end. Next slide. Next slide, please. Yeah. Why do we adopted BT cotton? I think our adoption has been the highest in the world. Why? Because of frequent outbreaks of helicobacter. I think I have seen as a cotton farmer, I have seen as a cotton researcher, and as a director cotton, that every alternate year our cotton yield used to drop because of the bollworm problem. And that's how I think the cotton BT cotton became very popular in the country, which many people do not understand of the pest. And then there are new hybrids which are coming. Next slide. The next transformation of cotton. Next slide, please. Yeah, you can see the adoption rate. Now this is the adoption rate is, I have repeated it almost 2002 onwards. And you can see the area and productivity. Next slide, please. Yeah, this is what I call it as. Now, the important part is that India was a net importer of cotton till BT cotton arrival. That is up to 2002. nearly 2 million bales of 170 kg each used to be imported to run our factory. Today, the situation is reversed. We have one stage of almost exporting 9 million bales, 90 million bales out of the 9 million bales. And now you can see that there has been a tremendous export growth, and simultaneously we have also sufficient stocks to run our own industry useful. So that has occurred in the cotton value chain, export and import of cotton. Next. Simultaneously, I think I have just give you figure 15, 16, almost 6.9 lakh bales, and 1920 about 5 million bales last year. Even this year in Corona's time, we are expecting that it will cross 5 million bales as export. Very interesting. And that's why the cotton is if you compare internationally, is the cheapest cotton. The export market will always be very beneficial to them. Next slide. This one particular slide I am deliberately showing because this impact which has carried on the staple length of Indian cotton is very interesting. If you see 7, we used to produce medium staple cotton 67%, 63% long staple cotton, and only 22% medium. We are now actually producing very small amount of short staple cotton. Now there has been a demand of short staple cotton, and now our breeders are now working on BT cotton in short staple. Next slide, please. Yeah, I think I need not about insecticide use because elaborately said that how there has been a continuous reduction in the insecticide use. Now we are almost stabilized, and for bollworms there has been, you can see the kgs of insecticide use, how this has actually reduced. Slide. I would like to also show one very important slide that is on the environmental impact. Because BT cotton in general delivered significant environmental benefit by reducing the insecticide usage nearly 50%. I am grossly telling you. But then what happened is that these sap-sucking pests of cotton and overall usage of insecticide may have slightly increased. But then we have all those, what we call it as the predators and parasites. They have actually, they are quite, yeah, their population has increased. So there is a benefit effect of the environment. Next slide. These are all socio-economic benefits. I think that is already covered. I need not. Next slide, please. Next slide. Here is very important because it is a multi-purpose crop. Next slide. Now, cotton is not only grown for the length. You have leaf fiber, 33%. Cotton seeds, very important. Then we have winters, hulls. We have also what we call it as the cotton seed oil. There has been a tremendous increase output. The moment we have adopted BT cotton, there has been a major output in all these areas. So this is very important. Next slide. The value addition of cotton is, if you claim nearly 12.5 million tons of cotton seed oil per year has been increased. So this, even the stocks, now there are a lot of factories which are coming on the cotton stocks. There are also oil, particularly I am more keen that the vegetable oil in the country is a problem, and that is how we have actually supplementary next slide. Next slide, please. These are some of the value added product cotton stock. Next slide. Next slide, please. Move to next slide. Yeah. Now, this is cotton oilseed production. You can see we are our requirement is 25 million tons of cotton oil consumption. And we are producing the vegetable oil only nearly 2 million tons. 15 million tons is imported. But out of these, 10 million, 0.5 million tons is provided by cotton alone. So this is where, otherwise earlier we used to have something, very few amount of the cake or the meal for the fodder is an important part. Next slide. Next two slides you can skip. Next. Again, yeah, future. Now we are looking for genomics. We wanted HDPS, cultivars suitable for mechanical picking, salt drought resistant hybrids, gene mining, and cotton also can hatch through these things. Next slide. So we are now looking that if we want a breakthrough in cotton, I think we need some more biotechnologies to really upgrade. Next slide. Next. HDBT trials are completed, but we are not permitted yet. There are FIRs lodged. These are illegal plantation of HDBT. 12 against 12 Maharashtra farmers for illegal sowing of BT cotton. Next. This is a news item, and still farmers are not worried. Despite ban, HT cotton is widely cultivated in Maharashtra. Nearly 15% area of central India is now covered by illegal, although government has not permitted. That means they want a technology where they can really save money on the labor, particularly hard-earned labor, which are spending a lot of money on weeding. Next. Next. This is now only just I wanted to show that how it is. Hello. Yeah, illegal cotton sales surge in Maharashtra and other states. Next. These are all news items which I thought very interesting. Times of India has given HTBT cotton grown illegally in 3 states, Telangana, Gujarat, and Maharashtra. Next. Now, cotton picking has been one of our major labor requirement, and with the advent of cotton high density, we are trying. There are some very classical work being done by the Indian seed industry to have BT cotton in the high density plantation material. Next. And our experience shows with the high density planting that if we have good hybrids under high density, I think this will give more yield. Next slide. We have some results of HTBT. You can see nearly the yield can increase from 12.5 to 16.87 quintal with reduced cost. So this technology is now being targeted by many seed companies. And in India, I think we will definitely have these things because India, cotton is the life for a large number of farmers. It's a cash crop for them. And therefore, they are ready to adopt any new technology. So I think I come to the end. Next 2 slides are only to say you thank you very much. King cotton has come back in the country, and it is because of BT cotton. That's what I said, that these are articles which have come. After BT cotton has come, King cotton also comes back. Thank you very much. Next slide, last slide. Now cotton is cool. India is the only country where we have nearly 60% utilization of cotton. In other countries, it is only 40%. And these are some of our heroes who are always using cotton dresses. Thank you very much.
Thank you, sir. Thank you, Dr. Mayee. That was very interestingly presented information about our experience with BT cotton. I think there was never any doubt about some of the benefits that you have presented today. but it's very good to see that we have not only improved yields, reduced cost, made our farmer more competitive, but also we have reduced pesticides use by close to 50%. Although the use on some of the sucking pests would have gone up because of the natural phenomenon of sucking pests going up when the chewing pest is reduced. But overall, still there is more close to 50% reduction in pesticides. Cotton seed oil, 1.5 million tons, which is actually a part of our edible oil portfolio now. And the need for herbicide tolerance because of the increased labor costs, and the need for mechanical picking and HTPS, which is showing almost 21% higher yields. Mechanical picking is becoming more and more necessary because the labor cost for picking is now almost 15 to 20% of the price. So I think these are all very compelling factors which point out to the need for more technologies, upgradation of technologies, and also the yield stagnation which is happening because of lack of new technology in cotton. So thank you very much for bringing out all these points. Now we move to Dr. Bansal. Dr. Bansal also is a very well-known person in our biotech circles here. Dr. K.C. Bansal is an adjunct faculty of the National Institute of Plant Biotechnology, IARI, New Delhi. He was formerly director of the National Bureau of Plant Genetic Resources, NBPGR as it is called, and the coordinator of the National Project on Transgenics in Crops. He has contributed significantly in the area of plant biotechnology, has published over 150 research papers and book chapters. Professor Bansal's research findings and outcomes are cited and used in crop improvement programs by several laboratories and institutions within and outside the country. He was the first to get selected for the prestigious Norman Borlaug Chair for Crop Improvement by ICAR. Professor Bansal was awarded the second highest award of the National Academy of Agricultural Sciences by the Honorable Minister of Agriculture of India. Professor Bansal is a fellow of the two prominent science academies, National Academy of Agricultural Sciences and National Academy of Sciences, India. He was educated at IARI and conducted advanced research at Harvard University in USA. Dr. K.C. Bansal, over to you, sir.
Thank you. Thank you, Dr. Ram, for the nice introduction. And I thank the organizers for giving me this opportunity to share the progress of the work which we are doing in India under the title Biotech Crops for Indian Agriculture. So when we talk of biotechnology and its role in agriculture, I thought it's better to first highlight what are the challenges which are faced in total by the global agriculture, but particularly by Indian agriculture. We all know about the climate change, and as a result, we have shrinking availability of these natural resources, land and water particularly, and there are emerging biotic and abiotic stress factors, and there's a big issue of or concern of malnutrition in our country. And also, of course, we're looking forward to sustainability production, in regard to agriculture. And so we're looking for some solutions. So I was asking a question, what are the solutions and the way forward? As a scientist to me, it appears that the application of these emerging tools of biotechnology to genetically improve the crops is rather important. And it's more important in a country like India, among all other countries in the world. We are one of the most populated countries in the world, and we still have 15 to 17% of our economy coming from agriculture. In India, to promote agricultural biotechnology, a department of Government of India was started in 1986, DBT, Department of Biotechnology, wherein we have been able to provide some of those tools to improve the crops using biotechnological tools. For example, we started with gene discovery, to genomics, to molecular markers, to marker-assisted breeding, genetic engineering and GM crops, and now we are, of course, talking of genome editing, which is further an improvement we all know over the technology we have on GM crops. And we have created an excellent infrastructure. There are several R&D projects in progress. There are several translational research platforms, particularly for GM crops. And there is a very good public-private partnership. And most importantly, we have a robust biotechnology, regulatory system. So what are those relevant traits for Indian agriculture? Here, there are several of them when we talk of agronomic traits or we talk of nutritional quality traits. Whole idea is to reduce the environmental impact of agriculture and move towards more of sustainability, way of production rather than utilizing those resources, mindlessly as we're doing currently, whether we talk of, and more importantly, is the enhanced use efficiency of water, nitrogen, phosphorus, potassium, or even radiation, or even land to increase the productivity and to save it. As Dr. Graham very well, presented, there's a lot of land which has been saved as a result of the cultivation of some of the GM crops globally. And with regard to nutritional quality traits, our idea is to address the malnutrition, and moreover, looking into the current pandemic, it is important to also look into the nutritional aspects of human beings to enhance immunity levels, which is very important. And this slide is, of course, has a lot of information, but that I thought is important enough from the contents point of view, particularly when we talk about agriculture, and those crops and traits which we would like to develop through GM route alone, not that conventional plant breeding is always important, that will ever remain important, but there are certain traits in crops which you can only be developed through the GM technology. And these are some of the crops I'm mentioning here, particularly with regard to oil seeds. India imports edible oil worth of 16,000 crores of rupees, which turns into billions of dollars. So therefore important that we focus first on mustard, groundnut, and soybeans, some of these traits. Pulses, again, we are not sufficient in pulses again. We import pulses worth of 14,000 crores annually. These figures are annually. And then both the crops, chickpea and pigeon pea, and we are largest producer, largest consumers of the pulses in India, in the world. And these resistance to port borer in both the crops is very, very important. There's a 40 to 80% at times reduction as a result of, this infestation, if it is high level, by these port borers. Cereals, of course, rice occupies a prominent position here, and it utilizes rice alone, insecticide worth rupees 2,500 crores, which is again running into billions of dollars. So apart from even saving these insecticides and protecting the plants and producing more, there's also the important issue with regard to global climatic change, as Dr. Graham Brookes mentioned, that we need to increase water use efficiency, nitrogen use efficiency, and also to develop solvent-tolerant crops, particularly I'm talking of rice. Similarly, other cereals, and direct seeded rice is becoming prominent to save water, which takes a lot of water when we talk of flooded rice, kind of here we're talking. But this direct seeded rice, important issue is again, we need for sure a herbicide tolerant trait. And similarly in other cereals, and again, vegetables, in general, in vegetables, to save them from insect pressure, we need about 12,000 crores of insecticides, which is again a huge amount. When you add it up all, you can imagine, how much money we are losing as a result of only saving these crops from some of these biotic and abiotic pressures. And then in fruit crops, we have got banana and papaya, and commercial crops, cotton, sugarcane, jute, and rubber for various different traits. So far, GM crops research in India, of course, there is a good amount of, I would say, R&D effort which is in progress, both by public and private sector. This is an advantage we have in India, that both public and private sector playing a key role in addressing some of those issues. And already, as you can see from here, 23 biotech crops we're working with. In the slide which I mentioned to you, if you add up all these crops, about 23, and in all these crops, there's an effort which is in progress. And there are total about 67 biotech traits or GM traits which are being worked upon, and there are different stages of development. And out of those 67, 39 traits are by the public sector and 20 traits by the private sector, and 8 are from the other autonomous institutions. And as you all know, BT cotton was our first product. We have heard enough, an excellent presentation by Dr. Mayee already. So I'm not talking about that at all. But immediately after BT cotton, the crop which was approved in 2002 by the apex body was this fruit and shoot borer resistant transgenic BT brinjal, as we call it. Though from a private sector, the event EE1, but then we do have from two ICR institutes, public sector, wherein different events have also been developed. But then the same event EE1, as you all know again, was commercialized in Bangladesh, and they have already released 4 different varieties out of it, and they're taking a significant amount of advantage in terms of reduction in pesticide use by 28%, and increased profit to the farmers by 49% alone from, not that it is so widely spread, but at the same time, this is the kind of good advantage Bangladesh is already harvesting, and we are at a loss in India at the moment. But that was 2010. Now, up to 2016, about dozen more crops, they are undergoing these biosafety research trials, by both, again, public and private sector for various important traits. And here, I'm going to highlight more about mustard, which is a GM mustard developed based on this bar star story of hybrid seed production. And this is what is GM mustard is already been again approved in 2016 by the apex body, though not yet commercially released. Not approved, I would say, it's been recommended for approval by the apex body. And here in this GM mustard, the advantage of the seed yield, you can get even up to 37%. If there are even conservative estimates, I'm very happy if we can get even 25% of advantage from the current levels of production. And these figures have been, in fact, drawn by even making all those, comparisons with the national checks, which we have a system here, a best system in the world of all India coordinated research improvement programs of various crops. So it has undergone all those tests, even from agronomic point of view, and Professor Deepak Pantel has developed this from Delhi University. And this is what is the second in line after BT cotton that we are expecting, for it to be released. Now, when we talk of these further approvals and down up to the level of 2020 after 2016, there are again, these about dozen of crops, you can say, both by public and private sectors, for various traits. And again, the traits which are predominant are, of course, insect resistance or herbicide tolerance or combined insect and herbicide tolerance, particularly cotton, as Dr. Mayee mentioned, HT/BT cotton is very, very important. But then they are again, at different levels of trial. And these are some of the meetings. The last meeting of the apex body took place on 29th of July this year. So this is, we are making a good amount of progress with regard to the conduct of these trials or approval from the apex body. And parallelly, in fact, from the public sector alone, I want to highlight this point particularly. I come from Indian Council of Agricultural Research. I was serving there for about 35 to 40 years. And then we developed one of the largest ever project, on transgenics in crops under ISAAA, the Indian Council of Agricultural Research, worth again rupees hundreds of crores in again about 20 crops in different traits, again insect pest resistance or drought and salinity tolerance, virus resistance, or fungal resistance, depending upon that these are the traits and these are the crops where conventional breeding will take a lot of time. It may not be even possible to reach there, as we have seen in case of BT cotton. But here again, there's an excellent amount of output, I can say, from in the last about 15 years. Started this work in 2005 with large number of institutions, as shown, not in this slide here, but several institutions, shown here. For example, in different crops, there are about 10 crops, for various traits, not only, resistance to insect pests, both pigeon and chickpea, but also abiotic tolerance, which is very important. Or in case of brinjal, again, insect pest resistance, but drought tolerance in case of tomato and in rice and many other crops. So overall, today, when we talk of 2020, we have about 83, events in different crops with different traits, 16 crops. And these are the ones, dominantly by, rice 23, cotton 20, maize, mustard, brinjal, etc. As you can see, it goes down even to the level of rubber and sugarcane, which are some of our commercial crops I mentioned before. But then again, with regard to biosafety, though India itself is doing all those kinds of analysis in all those biotech crops I mentioned before, but again, globally, if you talk about it, more than 20 years of data, in fact, 25 years, I would say, that the GM food safety and environmental safety data proves that all is safe with regard to biosafety, to human health, to animal health, to environment. And I'm very happy to see, some of the data presented by Brookes, and also this particular report says so. That is from US National Academy of Science, Engineering and Medicine, and there are 123 Nobel laureates attest to this hypothesis. I mean, this kind of analysis that yes, these crops are safe. And this particular, report also has exactly said, and many of these things which Brookes mentioned in his report. I don't want to repeat that, but coming down to the system in India we have, that's a very robust Indian system, I must say. I don't want to go into the details of it because of the time. But then, as our Honorable Prime Minister of India has announced India to be self-reliant, we call it as Atmanirbhar Bharat. So to be self-reliant, we feel that GM crops could be a very integral component to produce more in agriculture. So therefore, what as a scientist, I feel, I have been developing several of these GM crops myself, that a clear policy is needed for sure. Existing regulatory approval process needs to be accelerated. Approval from states should be there without delay. Political support is needed in favor of relevant GM crops. We just don't want approval for any GM crop which is important, which we cannot produce otherwise using conventional breeding methods. So therefore, these relevant GM crops, and by the way, just to extend, though this is not the topic for talk today, but then these SDN1 and SDN2 products without foreign DNA to also treated as non-GM. Because I was a part of a discussion by the National Academy of Agricultural Sciences, where I fortunately happen to be a member. This report has come out only recently, wherein we have recommended that these two type of products, should be treated as non-GMO, as many other countries, including USA in the world, have done. But why do we need all that? Simply because of sustainability and profitability to smallholder farmers. It's very, very important. And I believe, again, I have been personally involved through this National Academy of Agricultural Sciences, has been playing a very big role in promoting GM crops in the country. We have personally made intervention in Supreme Court case. There are several policy papers in favor of GM crops, and we have even written a letter. 50 eminent scientists have signed this letter, and to the Honorable Prime Minister sometimes in 2015. But we thought that yes, it is having some kind of an impact, and also there is a kind of an environment which is to be created, to me appears now, by NITI Aayog. This is our kind of a planning commission of India, where they're trying to bring some of the even opponents to the technology, or even supporters. Some of us, they have been invited, but the meeting, to my knowledge, has not happened yet, and we're waiting for it to move. Nevertheless, I think there's a positive environment for sure. Government will continue to back GM crops. That's what DBT Secretary says. And that was in July 2019, just about a year ago. And then in 2020, the future of GM crops in India is positive. It's a positive environment. And they're looking forward to some of these gains in terms of improving farm efficiency or sustainability and food security. I believe GM crops, as has been amply clear and demonstrated, by the report from Brookes, that it is possible improving farm efficiency, when you talk of sustainability or you talk of food security. So actually speaking, I've always been in favor of GM crops, particularly to drive benefit to the farmers. And India, we have the IPL cricket season going on. So I selected my own 11 actually of some of these crops with 2 or 3 extras. So this is BT brinjal, if it is approved immediately for commercial release, followed by GM mustard, and BT brinjal EE1 event, which have been already commercialized in Bangladesh, GM mustard, which is a hybrid mustard technology, HTBT cotton, virus resistant cotton, nitrogen use efficient cotton, and DST drought salt tolerant cotton. Dr. Mayee amply talked about it, that we need more of technologies apart from BT in cotton. Then of course, HTBT maize, BT chickpea and PGP both are very important. Rice, where we're spending too much of money on insecticide. And then again, rice should be also combined with drought tolerance and even this is herbicide tolerant rice, salt tolerant wheat. Nevertheless, late blight resistant potato is also very important, late blight resistant potato. And we have out of that network, which I was talking to you about, one of the products. At the end, I would just like to remind you all that this technology, about 30 years ago, when we started, an experiment by these 3 scientists in 1983, 30 years later exactly, Mark von Mentegu, Maribel Chilton, and Robert Fraley were awarded the World Food Prize in 30 years later. And today, when we know that there's Nobel Prize has also gone for genome editing to both these, intelligent ladies, we are very proud of it. But important is that these technologies, which have been developed either by these, World Food Laureates or by these Nobel laureates, it needs to be fully utilized for a country like India, more importantly, than anywhere else in the world, for product development, for agriculture, food and nutrition, or for human and animal health, or for environmental safety and sustainability. It's very important. So with this, I give a message, yes, that any science-led approach only can provide a secure, economically and environmentally sound and sustainable global food system. With this, I thank you all, but I also should not forget to thank some of my friends and colleagues who helped me prepare this presentation, particularly Dr. Ratna from FSSI, Dr. Monica Singh, my old colleague from National Bureau of Land and Genetic Resources, and others. I thank you for your patience. Thank you, Ram, and thank you, organizers.
Thank you, sir. Thank you, Dr. Bansal, for that excellent presentation. Very informative about what is in store. What is it that we can hope to get, provided the regulatory logjam is cleared and we have a more supportive general environment for the deployment of the technology. But I think it's very clear that you have identified some priorities like oil seeds, where it's very important, pulses, oil seeds, DSR rice. Many of the people who are in the participants here who eat rice don't know that it takes 5,000 liters of water to produce 1 kg of rice. Many of them don't know that. So if we want to reduce that water consumption and preserve water, we have to use DSR, direct seeded rice, and herbicide tolerant technology will be very useful to control weeds in such a situation. So I think there is a lot of priority area where fertilizer use efficiency, for example, which can reduce the use of fertilizers, which can reduce the damage to soils, because this is one of the big issues we have in rice and wheat and some of these crops where high use of fertilizers takes place. So I think fertilizer use efficiency, nitrogen use efficiency will be very, very useful. I think your Dream 11 list of crops is also very good. I think this is what we should try to firm up, that what are those priority areas where the technology can be useful in India. You have also brought out very nicely that how many crops have undergone trials and what is the mustard, for example, 25% seed yield improvement, which was proved in the All India coordinated project. Those are the benefits which we can expect, and especially in oil seeds where we are spending 70,000 crores every year on imports. And you made a very good point that the Indian regulatory system is very robust. So we should actually back our regulatory system. We should trust our regulatory system and go by what scientific studies they do and make their recommendations eventually. Because I think because it is the same regulatory system which has cleared your insulin and which has cleared other products which are called rDNA products, which are used by the people. I think there is no reason to disbelieve that their clearance of GM crops is not scientific. So I think field trials should happen, as you said. They should be a part of Atmanirbhar Bharat. Political support for relevant GM crops. I think this is also a very important point you have made. And government is backing it. Niti Aayog is backing it. There's no doubt about that. Large scale meta-analysis of safety studies was done by US National Academy of Sciences, and also EU undertook a study on the similar lines and then published a report. Both of them have concluded that the technology is very safe and there is no threat or danger to the human and animal health and environmental health. I think these are all very important points which should actually support the case for larger deployment, not indiscriminate, but larger deployment in relevant crops and for relevant traits in India for us to take benefit. And thank you very much for bringing out all those points.
Thank you. We must continue with our efforts.
Thank you, sir. Thank you. So we have heard so far 2 scientists, 1 economist, and we have also heard 1 information providing academy at the global level. What is happening on the GM crops and what should happen and what is recommended to happen in these crops. So there is an important link in this, that is a farmer. A farmer has to have his word and has to have the last word usually, because that's what matters to all of us finally. It is the farmers who have to speak out for what they need. And that is also something which we must actually support, because what the farmer needs is what we must support. I think that is what is very important for all of us to understand. And like Dr. Mayee said, the farmers have demonstrated their need for HT technology because of the shortage of labor and increasing labor costs. I think many of us should know that according to Government of India's data, between 40 to 60% of the cost of cultivation of farmers in different crops is from labor. The labor cost is the lowest hanging fruit which we must solve so that farmers' profitability can improve. And one of the ways to solve that is through use of weed management technologies and mechanization. I think these are the things which we must actually support. So coming to pharma, we have today Mr. Ravichandran. who is also a well-known farmer and farmer leader. He is the third generation farmer growing paddy, sugarcane, cotton, pulses, etc., farming for over 30 years. Ravichandran has formed United Progressive Farmers Forum to facilitate farmers to aggregate their resources and bridge the gap between the farmers and the consuming industry. He is the vice president of the national forum called Indian Farmers Network. He is also the global director of Global Farmer Network based in Des Moines, Iowa, USA. As a strong proponent of technology and science, he firmly believes that the farm productivity can be increased only through the adoption of scientifically proven technologies, including environmentally sustainable farming methods, farm mechanization, empowerment of women in agriculture, bioengineering, and through mutual cooperation with fellow farmers. He has been playing a major role in developing the mobile-based app by the world-renowned institutes using artificial intelligence to diagnose plant diseases and pests. Ravichandran also writes in various magazines in Tamil and English, emphasizing the need for modern technology in farming. So we have Mr. Ravichandran with us, and we are very glad that he is joining us from his home, from his village. And it is also great that his Wi-Fi and his connectivity is holding up, although he's speaking from a remote village. Thank you very much and welcome. Yeah. So, Mr. Ravichandran, over to you.
Yeah. So, yeah. Good afternoon, everyone. At the outset, I would like to thank ISAAA for providing this wonderful platform to share my thoughts. I don't have any pie charts or graphs, statistics or bar charts, but however, I'm going to share my experience for 34 years experience in agriculture, and I have been growing cotton for 34 years. I'm going to share my experience, 34 years of experience in cotton in this 15 minutes. Yeah, next slide. So I have been farming for over 34 years. I grow rice, cotton, and pulses, and coconut also. Yeah, I'm a proponent of good technology. Next slide. So way back in the year 1986, immediately after completing my college education, I entered farming. So the day I started farming, I started growing cotton also. Those days we had only open pollinator variety. So we had MCU5, MCU7, Varalakshmi, and such varieties, SVPR, and such varieties. From 1986 until 1999, I was growing only open pollinator variety. So I heard about hybrid in the year in mid 90s. So I decided to go for hybrid variety in the year 1999. So when BT cotton was introduced in the year 2002, but however, I took up BT cotton cultivation only in the year 2004. Let me slide. So those days, you know, that was a very nightmarish experience. So our bollworms, you all know the three bollworms, Helicoverpa, pink bollworm, and spotted bollworm. Besides this, you have this Pedoptera. So they devastated our crop. They inflicted huge economic loss to the farmers. So those days we even, you can see all over our field, you can see a lot of balls and squares spreading like mat all over the field. We used to pick those balls so that, pupae don't develop. We burn it. We spend a lot of money on such agronomic practice also, entomology practice also. We used to spray different kinds of chemicals. So we call it calendar spray. On Monday, we will be spraying one insecticide. On Tuesday, another one. On Wednesday, and by the weekend, about different kinds of at least 3 or 4 insecticide. Again, we go for a combined cocktail of various chemicals. So none of which had any bearing on that. They didn't control these bollworms. So besides these chemicals, I even tried out these biological controls. I used nuclear polyhedrosis virus. Besides, I used these light traps, then pheromones. I tried whatever suggestion made by my fellow farmers or by the extension staffs, I used to adopt it. But these pests are too smart, and I was totally defeated. Like me, a number of farmers were defeated. Rather, these pests developed resistance instead of these chemicals, eliminating these pests. They started developing resistance against all kinds of insecticide. So it drained all our resources. I fell into a debt trap. I borrowed from banks. Then banks refused to lend me. Then I had to go for the private money lenders. So that was the sad situation that was prevailing in those days. Prior to I started growing BT cotton. So I was rather so desperate. I was in the verge of giving up cotton cultivation itself. So enough is enough. Let me not grow cotton. Let me try some other crop. So that decision I had come. Though cotton is a cash crop, I decided, at one point of time, I decided to abandon the. Next slide, please. Yeah, I said I started growing cotton only in the year 2004, BT cotton only in the year 2004. Though BT cotton was introduced in the year 2002, I dragged my feet for about 2 years. This is because I got carried away by the false information. So whenever you open a newspaper, you'll see all kinds of misinformation, false information. It's very scary. It is, it is scarier than some of the horror movies. Cattle grazing in news report said that if you grow BT cotton, then you cannot grow any other crop. So that's all. Your soil would be dead. All soil organisms would die. In Tamil, we call it mannu maladapedum. So that was the situation. Then if you grow BT cotton, then none of the other insects would survive, and they all would die. And again, the cost of the seed material is higher, and there is no point in spending so much on the seed material. Next slide. Next slide. Yeah. So as I said, I wanted to give up cotton itself, or cotton cultivation itself. So that was the situation. Then, fortunately for me, there was a meeting organized in Coimbatore in 2004. In the month of February, there was a meeting organized by South Indian Cotton Association, SAICA. So there was one session. So out of mere interest, I wanted to know how to control these bollworms. Coimbatore is about 320 kilometers from in 4 different buses to reach Coimbatore. I took a small room near the railway station. Still remember, I attended the meeting in the SAICA, a meeting organized by South Indian Cotton Association. Fortunately for me, one of them was about this BT cotton. I still remember Dr. T.M. Manjunath. He made a presentation. So I bombarded him with a lot of questions. So I was fully charged with the false information I had in my mind. I bombarded him with all kinds of questions. He patiently replied all my questions. He said that instead of he explained everything, then he suggested, Ravichandran, after the meeting, Ravichandran, why don't you go and try at least 1 acre of BT cotton and grow 1 acre of non-BT cotton, and you decide yourself. So you make a comparative study. If you feel that the BT cotton is good enough for you, you go for BT cotton. Otherwise, you keep fighting with these bollworms in your own way. So that is what he suggested. So on my way back home, I got down at Kumbakonam, bought seed material needed for BT cotton seed material for 1 acre, and bought its non-BT counterpart, that is hybrid, non-BT hybrid, And I have this open pollinate variety MCU7. So initially I thought that, okay, science, I trust science always. So I thought, okay, anyway, I would be making some benefit by way of reduced pesticide expenses, but let me see how much I'm able to save. So to my pleasant surprise, I could realize much more direct and indirect benefits what I had anticipated. Next slide. Yeah. So I, on the same day, I took up the cultivation. I took up the sowing of this hybrid BT cotton, hybrid. It's non-BT hybrid, non-BT version of that hybrid, and then uh, what is the seed cost, what is the sowing cost, and the land preparation cost, fertilizer and nutrient, everything I meticulously I logged, so I can even share with you whoever wants it. I can, those days now I made a comparative study. Between its, I made a cost benefit analysis, differential cost and incremental revenue. Next slide.
Well, turn on video on.
All right.
No, not
Yeah. Open pollinator variety, and BT hybrid, definitely it is more profitable than its non-BT hybrid. See, next slide, please. Next slide. Next, yeah, this one. See, I tell you why BT cotton is more profitable than its non-BT hybrid counterpart. So this is because in order to increase profitability, this is true for all crops. So we have to increase in yield per acre. We have to reduce cost of cultivation. We have to increase the unit selling price. So the synergy of all these three factors, it results in increase in profitability. Let me explain how I could achieve increase in profitability, these contributing factors, in the following slides. Next slide. See, actually, the yield of cotton depends on the number of squares and bolls that such in the plant that we all know. So we say that 120 bolls, 150 squares. So which ultimately decides the yield potential. Again, the vigor of the plant is also important. See, these squares and bolls shed due to various biotic and abiotic stress factors. The important factor that is responsible for boll shedding is the bollworm. So again, BT cotton, the boll shedding is practically nil. It is non-existent. So because in BT cotton, the boll retention rate is it's relatively higher. So which ultimately translates in higher yield. So again, the plant must enjoy unhindered vigor right from the day we start sowing it. So again, the spotted bollworm, first it damages the tender fruit portion when the plant is about 25 days old. Then it restricts its growth. So in BT cotton, this is not going to happen. So the plant enjoys unhindered vigor right from the day we sow, and the boll retention rate of relatively higher, which ultimately translates into higher yield. This is the reason for the higher yield. So though BT cotton is not meant to increase the yield, because of the restriction of because of the absence of these bollworms, the yield increases. Next slide. Next slide. Yeah. So this is my cotton. You can see number of robust bolls. Next one. Next. Yeah, this is a fluffy cotton. Next, all taken in my farm. This is me standing in the Barbadans variety. So this is I'm standing in front of the my cotton stock in the mandi. Next slide. Again, so the next point is cost reduction. So as I said earlier, there is a tremendous savings in terms of pesticide cost. So maybe the cost of pesticide as well as spraying cost. So there's, I could save enormous quantity of enormous money by way of reduced pesticide expenses. I had to spray only 1 or 2 sprays only to control the sucking pest. Then again, in open pollinator variety, we maintain a spacing of 2 feet by 1 feet. That means we have to nurture about 22,500 plants per acre. So whereas in BT cotton or hybrid cotton, so which is non-BT, if it is hybrid, in India we have only this trait only in hybrids. So the spacing is 3 feet by 3 feet, or some wherever the land quality is good, we maintain 4 feet by 3 feet. And the cost of sowing and the cost of placement of fertilizer, it's relatively low in hybrids than its open pollinator variety. And see, since we are leaving a gap of 3 feet, we can use the power tiller for the intercultural operation. Again, the harvest labor efficiency also increases because I have experience. So I used to pick along with my farm hands. I also work with them. So whenever I pick cotton from the open pollinator non-BT cotton those days, so because of the bollworms, it is very difficult to pull the kapas. It is very difficult. I made a time and motion study. So because, in BT cotton, the bolls open fully. It is easier for the farm hands to pick, harvesting laborers to pick cotton. So the labor efficiency also increases because of the absence of bollworms. Next. Next slide. Where, this is my farm, and so this is my power tiller. So I use this power tiller between rows. Next slide. Next slide, please. Yeah, next slide. Next slide. So you can see on the left side the cotton affected by the bollworms, and you can see fluffy cotton. So I said, so one may ask, so how come the BT cotton fetches better price? Because the cotton seed, as we all know, it is an oil seed, so it secretes oil. When the bollworms, they damage the seed also, so it secretes oil, it contaminates the. So the traders buy only the pure cotton, contamination oil, cotton free from oil contamination. So again, through these entry and exit points, fungus and bacteria enter and damage the fiber. So the Ginners and Millers, without mentioning that it is BT cotton, those days they offered me the better price than its non-BT counterpart. Those days in 2004, I used to take both BT as well as non-BT cotton. They used to offer me better price for my BT cotton without mentioning that it is BT cotton because of its they provided extra, extra money for my cotton crop. Next slide. Next slide, please. Yeah, there are other benefits. Professor also, Dr. Mayee also mentioned non-target. Since we refrain from spraying any insecticide, the non-target are preserved. Ladybird beetles, you can see it's fluttering all over. You can see honeybees. The environment is not polluted. Those days, if you entered my field, entered any village, cotton growing village, you will be welcomed with the booming noise of these sprayers and the pungent smell of different kinds of insecticide. So you can imagine how it would happen, how it would affect the lung during the COVID season. This is the this is the environment benefit. And again, the labor efficiency increase. And again, both for the farmers as well as the industry, there is a win-win situation. Next slide. Next slide, please. Next slide. Next one. Next one. Next, yeah. And there are, mentioned that I was carried away by these myths. So this is a common sight in any village. You can see cows and buffaloes and other cattle, they graze in the cotton field. So there was, whenever you open hundreds of cows died by grazing in the cotton field. Some veterinary doctor gave some kind of certificate that he made an autopsy and said that they died because of in our cotton field. This is the common side. Next slide. Next slide, please. Next slide. Yeah. So this lady, she is done with the harvest. She is, grazing her cattle, and these goats, they enjoy they prey on this. They enjoy the delicacy of BT plant. Next slide. Next slide. Again, so this is one important observation. So this is my cotton field. My farm laborer. I asked him to dig in the cotton field, and I asked him to pick out the earthworms. He's on this side you can see this on the right hand side you can see the earthworms, lot of earthworms. So see, this is BT is a soil-based organism. If it is really harmful, except this BT, no other organism would survive in the soil. It's harmless. So it is, this is another fearful story that some of the activists were spreading around. Next slide. Next slide, please. Again, so this is sent by my friend from Maharashtra. So so you can see the honeycomb. This is the honeycomb in his cotton field. So you can see a lot of honeybees. Since we refrain from spraying any insecticide, we don't drive away the honeybees. The pollination takes place very well in my cotton field. Next slide. See, actually, fortunately for the cotton farmers, and unfortunately for the rest of the farmers, except cotton, we do not have any other trait incorporated GM crop in India. We are fighting for right now. We are facing some kind of some parts of Andhra Pradesh. They are facing flood condition, and some places drought. We need the flood tolerant and we need to have a more nutritious crop. Recently, I read in that is innovated by one Dr. Rathur, an Indian scientist. So FDA has approved it. We need to see even malnutrition by growing cotton. Next slide. See, all sectors of the society, they enjoy the benefits of science and technology. They are denied of the technology. So whenever we want to use technology, then again, so I'm an insulin. I'm insulin dependent. I take insulin shots. Thank God these activists don't object to the insulin, because some bacteria produces insulin. It is cheaper for a farmer. It is cheaper for putting that humulene. So fortunately, they didn't touch upon the humulene so far. So other industries enjoy the technology. Why not the farmers? So we have GM mustard and GM eggplants. So these are all the needs of the farmers. And our Prime Minister, late Prime Minister Pandit Jawaharlal Nehru used to say, Dr. M.S. Swaminathan used to quote that everything else can wait, but not agriculture. Unfortunately, in India, agriculture, be it the agriculturists, are made to wait forever, and technologies are in the cold storage forever. This situation must change. Thank you.
Thank you very much, Mr. Ravichandran. That was very forceful and passionate message coming from the heart of a farmer who has seen the prior period and also the subsequent period of introduction of the technology. Because I was in the pesticide industry 25 years back, 30 years back, and I know how cotton farmers used to spray pesticides 20, 25, 30 times in the field just to control the bollworm. And so I think you brought out all that very well. You also brought out all the information. I remember when the gas stove came for the first time in the late 60s, there was an information spread that if you cook on the gas, it will cause harm to your health. The food will cause harm to your health. So those kind of things do come whenever new technology comes. I think some kind of information is spread like that. But I think we have to take into account the final product, considering everything through self experience as a farmer, what you have seen, what you have felt. I think these are all important things. Thank you for bringing out all these things. You brought out how yields went up, how price went up, and how costs came down. I think this is a very simple formula actually to improve profits. So you improve yield, improve price, and reduce cost. I think you have done that. So thank you very much for bringing out and also all the beneficial insects protected, honeybees protected, and all that. So I think it is a very, very nice presentation. Thank you very much. So now we will try to address some of the questions which have been coming. So one of the questions is that
excuse me, Ram, can we go for poll number 2, please?
Okay. All right. Yeah. So there is a poll again. So please look at the questions and then answer them. Poll has ended. These are the results.
Let's see, almost 1 minute.
Impacts of crops are consistent and well documented in peer-reviewed studies. So 80% are saying true, 9% are saying false, 11% are saying not sure. Okay. All right. So let's go to the questions. There are a few questions which we can try to answer. So one of the questions I think which has come is that I think Mr. Ravichandran answered this in his presentation, but it was still there. How come cost of land preparation and fertilizer cost are higher in the varieties, non-BT varieties compared to BT cotton hybrids? I think you explained that with the spacing and the number of plants and then the fertilizer replacement costs and all that. Okay. There is a question about what are the associated risks of consuming BT cotton oil? Can Dr. Bansal answer that? Are there any associated risks? Are there any associated?
There are absolutely no associated risks. As I told, it has become almost a part. In Gujarat, you will find cottonseed oil is regularly consumed. And there is already an association that is called as All India Association for Cotton Crushers Association. And the head office is in Maharashtra, Bombay. So every year there are people who are now crushing oil. So mainly because they are removing gossypol, which was the earlier problem, and gossypol. Now there is a technology also which has come in US where we are producing gossypol-free cottonseed. But that will take time. But till then, chemically we are removing it here in India, and the oil is available everywhere. It is also available as for mixing with standard oil.
Thank you.
And by the way, sir, whether it is BT or not BT, so the gossypol is going to be there. So even in BT, non-BT cotton, the gossypol is going to be there.
No, soybean oil, which is being imported to our country, India, and we have been consuming it, it's also an oil. In fact, it's a GM oil. And we have no such report, truly speaking, that it has got any ill effect or any adverse effect on human health at all.
Okay. So there is another
5
question to the
million
science.
tons of soybean oil is being imported in this country. 5 million tons.
It is GM oil. Yeah. Yeah.
Already
There
it
is
is.
Yeah, sure, sir.
And
Thank
also
you. Yeah. Canola. Yeah. Thank you. There is another question to the scientists. I think between Dr. Mayee and Dr. Bansal, you can look at this. The effect on native gene pool due to the introduction of transgenes is not discussed much. Is there any effect on the native gene pool?
There is no effect at all. And please don't say that it's not been discussed much. There's a lot of literature available on it. Truly speaking, as a scientist, I can tell you, there are examples, even with the use of BT cotton in our own country, the biodiversity has increased. So people are talking about transferring of genes horizontally or otherwise to related and wild species, and it would probably destroy the agrobiodiversity. There's no such case at all. No, but there was a lot of hue and cry when we're talking about BT brinjal in our country. First of all, we must look into the geographical area where that particular GM crop is going to be released, whether there are any wild species around in that region at all or not. If there are no wild species occurring at all, there's nothing to worry about it. But even otherwise, like we have some wild species in India, of brinjal, but they cannot be crossed so easily, even by human intervention. Even if scientists want them to cross, it's very difficult to get this seed. Even if we get that F1 seed, at times it's not even fertile. I mean, it's not viable. It won't even, kind of germinate. So therefore, there is no such report that we can talk about it, particularly with regard to GM crops, though there are otherwise hybrids being produced, conventionally bred crops are there, and we have not seen any such effect, of horizontal gene transfer, you talk about it, or even otherwise from one crop species to another crop species. Okay. Such effect. Nature takes care of itself.
Thank you, sir. There was a question which someone asked about Maharashtra farmers got benefited, but Punjab farmers did not get benefited. So I think I'm reading out the yield data between 2002 and 2013. Punjab has seen 149% increase in yields. Haryana has seen 145% increase in yields in cotton. Whereas in Maharashtra, it is 125% increase in yields. So I think there is a considerable increase in the yields of Punjab and Haryana also. In fact, higher than the yield increases in Maharashtra. So another question is that how come we are not being allowed to have iron and vitamin enriched rice in India? Any golden rice, sir? It's your project. So
golden rice.
What is coming in the way of golden rice in India?
No, in fact, I can tell you something about golden rice. We had one event of golden rice, as a donor to transfer this, beta carotene content into our Indian varieties. And that was supposed to be done by 4 different institutions, including some state agriculture universities and institutions of, ICAR, even IARI. And that backcrossing was done. In fact, to attain homozygosity, it is important, in any crop for that matter, when you do backcross breeding. But then if you obtain homozygosity, which we did in case of Swarna, Dr. A.K. Singh, who is currently the director, he did all that work. And that there was some kind of a problem, actually, in the sense the panicle was not able to emerge it out thoroughly in those lines. So also this adds into the kind of fact that scientists are themselves more concerned about that no such product, if it is not useful for the farmers enough or for the consumers, will never come out of it. So there was some little issue, technical issue, that the gene for that beta carotene content in the donor species was disturbing an auxin biosynthesis gene. I mean, any other gene which was which will help otherwise in promoting plant growth and development, particularly the ear coming out, and elongating it enough as it happens in normal rice. So there was little problem, and technically this has been published in some of the very good scientists, including Professor from the university. So therefore, there was a problem. But yes, iron rice, they are being developed. They are also in the pipeline, and they are at the R&D stage for sure. Dr. Swapan Datta's laboratory in Kolkata University is doing it.
Okay. Another question, sir, is that why hasn't any other new gene source identified to provide a choice to farmers? This is about BT cotton. Why there was only one source of BT gene and now other source was offered to the farmers?
There are other sources also, the vegetatively induced proteins, big proteins, there are certain protease inhibitors, etc., etc. But we don't have to worry too much about any other source as long as we get 100% protection with a single gene. And those genes are not single one gene. They are different classes of genes. They are for different insects, specific to different insects. Not the same gene work. If there is an insect is leptospiround type, there's a different gene. If it is another class, coleopteran, this is a different gene. So for different classes of insects,
no, I think the question was about BT cotton. I think there were 5 sources approved in India by GAC. GAC approved 5 sources.
Already
of
approved.
BT. Yeah.
Approved 6 events.
6 events, yeah, correct. So they were available in the market. It is just that the farmers chose to grow only one of them.
Because of the good variety hybrid, they are already having the normal BG2. That's why it is popular.
Okay. There is another question.
Any other
perhaps Graham or anyone else can answer this. The question is that why Burkina Faso stopped BT cotton?
Right. Yes. In Burkina Faso, there has been a temporary stop on growing GM cotton, and that's actually nothing to do with the technology. It was due to difficulties that the farmers had in selling the cotton from the varieties that the technology was in, because the fibers are shorter than what the cotton users in the markets in West Africa particularly want. So the government decided to stop the approval for growing the GM varieties until the technology was back crossed into varieties that have longer fibers, and that will result in, I think, possibly next year, the reapproval of the technology in Burkina Faso. I know certainly that the area and the production of cotton in the country has gone down quite a lot since the ban was introduced, but it will be reapproved once it's in varieties with longer fibers.
Okay, so I think what you are saying.
Yeah. Technically, if I may add,
I had been to Burkina Faso. Hello.
No.
I had
Dr. Mayee, please. Yeah.
Burkina. The basic what Graham says is right. It was the issue of really back crossing to the local varieties, which were not suitable, and that's why they were rejected in the market. But now, because the people have realized that they have a lot of problems, because there is already an outbreak of the bollworms there sometimes. So now they are coming back. So there is a lot of improvement going on.
Okay.
Our African Biosafety Committee there.
Okay, thank you. Dr. Bansal, this question is addressed to you specifically. What are the evidences that GM mustard trials were conducted as per AACRP protocol? What are the evidence that GM mustard trials were conducted as per AACRP protocols? In fact, most of the protocol was not followed, including correct check was not used. HT GM hybrid mustard was not compared with hybrid.
No, HT mustard, actually speaking, is not something to be compared with here. There's no, we're not talking of herbicide tolerance in the GM mustard at all. The herbicide gene is only used to select out those transgenics compared to the non-transformed cells. And it is only utilized for the seed production point of view. So let's not please talk about compare here. Herbicide tolerant trait we are talking about in this GM mustard hybrid developed by Professor Deepak. Here it's only Barnase and Barstar kind of a combination of genes which will kill the pollen. Barnase will kill the pollen. It will make plant male sterile. Barstar will restore the pollen fertility, and those two lines combined, and there's a whole procedure of hybrid seed production, and hybrid seed only will be sold to the farmers. So point here is that let's not compare with that. And otherwise, I have myself monitored. I was a member and involved as a member of a committee, a subcommittee of the apex body, GAC, and I have myself visited those, actually speaking. You know, so whatever the procedure has been all followed, I would say this, you know, in all these.
Thank you. Dr. Mayee, this is for you. What is the future of HTBT cotton in India? What do you think will be the future of HTBT cotton in India?
You see, there is a big organization called as Shetkari Sangatna. They have openly already planted and they have celebrated also that we are going to plant it. Kindly come and arrest us. Nothing has happened because the High Court has stopped everything. What I feel is, if this situation, see, there is a one danger in this. The danger is because all the seed is coming either from Telangana or Gujarat, and they don't give any receipt. I am only worried because I have been warning them that you will be cheated after some time, and there may not be any kind of HT or BT genes in them. But then what will you do? They say, no, we are sure that we will get it. And they are also putting a lot of pressure on the government. Maharashtra government has already this year said, okay, you go ahead. They did not object to it. So it appears that there is a case pending with the Minister of Environment, and Minister of Environment wants to call back probably buyer or Mayee, whether they can revise the application and all this. So it's a very long drawn process, but I'm happy that the pressure is being put on.
Okay, thank you. One final question. I think we have already overshot the time, so we'll take this last question. What is the current scenario and potential of gene-edited crops in India?
I think this gene-edited crop work is already in progress in India in several labs. You know, it started with banana transformation in one of the Agricultural Biotechnology Institute of DBT at Mohali. Then genome-edited rice with one of the drought stress tolerant gene, you know, by Dr. Vishwanathan at IRI New Delhi, you know, wherein they have shown that there's a remarkable increase in drought tolerance, in fact, in those plants, because these are the products wherein a single gene could be mutated as a loss of function. And loss of function gives you some kind of an advantage of plant growth. And ICGEB people are working, in fact, and DBT is taking a lot of interest, in fact, in having these programs, genome-edited crops in the country. Guidelines are being developed, which are being discussed at the GAC level at the moment. And I believe there is a good scenario looking forward to on genome-edited crops in our country. But the only thing is, you know, as a recommendation of this particular webinar, if there is any, we must try to recommend that the kind of mistakes, if I may say, we have done in India, for example, with regard to the adoption of GM technology, which is so good a technology is world over, people have seen it, we should be rather fair enough with this technology, which is more precise, more accurate, cost effective, more efficient. Genome-edited technology must be utilized, you know, the way it should be, actually benefit of farmers.
ISAAA is also doing. ISAAA is also having a program on gene editing. So there are a lot of institutions, yeah. And now I have already written Dr. Bansal. I have written it to a NAS. NAS should really conduct a program of brainstorming on genome editing now.
Right. No, genome editing we did.
Yeah, we are
document. Yeah.
Yeah. Okay. No, that draft guidelines are there, but the final guidelines have not come. It is only under draft stage. So that is another pending issue, and therefore I am asking us now to really have a brainstorming. Yeah.
I will look in.
Okay. Thank you, sir. Thank you all very much for answering all the questions. I think it was a great discussion, excellent presentations, followed by some very straight answers to some of the tough questions about the technology. We do appreciate all of that very much. So we will, before we go to vote of thanks and the summary by Dr. Mahalakshmi Arujanan, who is a global coordinator of ISAAA. Before that, we will have the third poll, right? There is a webinar poll. Yeah, the questions are here. Please, question is here. Please answer this. What topic on crop biotech would you like to know more about? Food safety, environmental issues, health issues, new products, labeling, coexistence of GM and organic, international trade. So here are the results. 28% said coexistence of GM and organic crops. They would like to understand more. 26% said environmental issues. 28% said health issues and concerns. 18% said food safety. 24% asked information. Sorry, 16%. Sorry, I was reading the 16% asked for new products. 19% asked for health issues. 17% asked for environmental issues. 12% asked for food safety. 28% asked for coexistence of GM and organic crops. And 5% asked for international trade. Thank you. So that gives us an indication of what are the subjects to be addressed in perhaps some of the future webinars. Thank you very much. So that brings us to the end. I now request Mahalakshmi Arjanan, Global Coordinator of ISAAA, to summarize, to wrap up and give vote of thanks.
Thank you very much, Mr. Ram. I think you have done a very good summary after each speaker, so I don't think I need to do that, but just a word of thanks. So to everyone, Vanakkam, Namaste, and Namaskar. On behalf of ISAAA, I would like to thank Alliance of Agri Innovation for hosting this webinar, and our partner, Federation of Seed Industry of India, for your support. Thank you, Mr. Ram, for moderating this session very well. You did such a great job. And I think this is one of the very rich discussion that we saw. In fact, I'm looking at this discussion and I see the hunger for technology, as well as a lot of questions that need to be answered. And of course, thank you to our esteemed speakers, Dr. Graham Brookes, Dr. C.D. Mayee, a strong partner of ISAAA, Dr. Bansal, and my very good friend, farmer friend, Mr. Ravichandran. All of you, in fact, have been long-time partners of ISAAA. Just like ISAAA's data on global status of commercialized biotech crops, Dr. Brookes' data on socio-economic impact of biotech crops helps many key stakeholders around the world to make informed decisions on the approval and adoption of biotech crops. Socio-economic impact is a contentious topic, and I am a regular delegate to COPMOP meetings, which is organized by Convention on Biological Diversity. And this is very much discussed in those meetings. And Dr. Brookes' data sheds a lot of light in this topic, together, of course, with all the other speakers. India is definitely a key agri producer in the world, and there is so much of innovation in the pipeline, with many GM crops waiting to reach the farm. I wanted to say more than a dozen, and from Dr. I think it was Bansal's presentation, I saw that there are 23 crops that has been developed, and many other traits as well, 60 plus traits. And many of them are almost at the tail end of R&D. So what we need here is a political will, public awareness for crops to be approved and adopted. And this is where ISAAA plays a key role in facilitating transfer of knowledge and engaging various key stakeholders. Dr. Brookes' data and information from other speakers clearly show the socio-economic benefits of biotech crops. And I'm glad that gene editing was also brought up in the discussion. These are the new tools that's going to open many more doors, especially to developing countries, as this is where public sectors and small enterprises will be able to be players, because all this while we've been seeing multinational companies. These NBTs, or new breeding technologies, will create more technopreneurs among our young graduates. And both GM technology and NBT, together with conventional breeding techniques, will all serve to address climate change, food, nutrition security, job creations, and more importantly, ensuring that all these are done sustainably. I personally think it's not just about feeding the world. We have been talking about feeding the world. We've been talking about food availability. But what is close to my heart, also as a teacher in the university, is that the newer challenges are getting young farmers to take up agriculture as a profession. And this clearly shows that GM technology is a key addition to the current toolkit that we can no longer ignore. Looking at all this positive data, ISAAA is confident that we are on the right track in supporting developing countries to embrace green technologies for crop development. We will continue to do with our outreach program in India, everywhere, and capacity building programs, and even new approaches to achieve our objectives. So with this, I'm wishing India all the best, and please continue your good work. We need a leader among developing countries for innovation in agriculture, and India certainly is a potential candidate. My last message is for the critics of GM technologies. Please speak to the farmers before you speak for them. Farmers like Mr. Ravichandran are asking for more biotech crops to be developed, approved, and adopted. Let us support them. So with that, thank you very much, Nandri and Dhanyawad.
Thank you. Thank you very much for your message from Malaysia. Thank you very much. Thank you all. Thanks for your participation. Thank you.
Thank you. Thank you very much.
Thank you.
Thank you so much to our panelists, Graham, Dr. Mayee,
Thank you, Aldemita.
Ravi. Yeah.
Thank you.
I will email you all.
Thank you.
Thank you so
Thank
much.
you very
Very much.
Bye. Thank you, Maha.
Bye-bye. Thank you very much. Bye.
Bye-bye.
Bye.